Welcome to Everything is Changing. In each episode, we focus on circular economy, ecosystem restoration, energy transformation, sustainable mobility, and water resources. I am Ahmetcan Uzlaşık. Perspective is everything, and everything is changing. My guest today is Stavroula Zervopoulou, a researcher and engineer with a unique blend of expertise in mineral resources, energy economics, and petroleum engineering. She is currently a research project assistant at the Vienna University of Technology and serves on the executive board of the EU-funded Horizon Circular Fuels project. In our conversation, we talk about turning agricultural residues and waste wood into sustainable aviation fuels, the challenges of scaling advanced biofuels, and the wider role of circular economy. Welcome, Stavroula, to Everything is Changing. Thank you for your time.
Hello, I'm John. Thank you so much for having me, and I really appreciate the opportunity to discuss the topic of feedstock.
I hope the weather is nice in Greece right now. I'm sure it is. Brussels is, as usual, a bit slippery.
It's a bit hot, but not how it was in the previous week, which was very hectic, to be honest.
Well, I can only imagine. So let's start with a quick intro. Could you tell us very briefly about the Circular Fuels project and what your role in it?
Yes, of course. So the Circular Fuels aims to produce sustainable aviation fuels from waste biomass by coupling of fast pyrolysis with solar energy. And the Circular Fuels project aims not only to produce SAF through advancements in renewable energy technology innovation, but also the main objectives are to prove the effectiveness of an innovative technology to couple solar energy fast pyrolysis of biomass and to maximize the profitability of the concepts. So as for my role in this project is that I mainly work on work package 6 that focusing on scale-up perspectives, exploitation and policy recommendations with TUV leads.
The project, as far as I understood, turns things like farm leftovers and waste wood into jet fuel. Pretty amazing stuff. What kinds of agricultural residues and wood waste are actually used in this process?
Oh, that is a great question. Let me break it down into two main categories of feedstocks we are using. First, we have waste wood. This includes materials like demolition wood grade B, which is typically wood and that's been treated with coatings such as paint or varnish, but is still classified as non-hazardous, as well as pine wood sawdust, a common byproduct in wood processing. Then, we have agricultural residues, and by that we mean things like straw from wheat and dry crops. All four feedstocks are low-cost, bio-based materials, and importantly, they do not compete with food production. Furthermore, both categories are recognized in the Renewable Energy Directive 2, specifically in Annex 9, which lists sustainable feedstocks for advanced biofuel production. We have done a thorough assessment to make sure everything aligns with those criteria. Now, under the updated RED 3, there is even greater emphasis on using waste and residue-based feedstock, especially to meet new stricter targets for renewable energy in transport. This includes specific sub-targets for advanced biofuels and renewable fuels of non-biological origin. What is really important here is that RED 3 does not just promote these materials, it also reinforces sustainability criteria. That means continuous assurance that the feedstocks we are using do not compete with food crops or lead to negative environmental impacts. So, overall, the project is fully aligned with RED 3's push for sustainable, circular, and low indirect land use chains feedstocks, all of which help contribute to the broader renewable energy goals in the aviation sector.
You talked about feedstock. I want to ask, and where do you find all this material, this feedstock as it's called, that gets turned into fuel? Are there any specific regions in Europe it comes from?
Yes, initially we focused our research on 3 countries, France, the Czech Republic and Denmark. These were our starting points for assessing feedstock availability and regional potential. But as the project progressed, we expanded the scope to include all 27 EU member states. That broader perspective gave us a more comprehensive view of what is available across Europe and importantly help us identify potential synergies between different regions, which can be really valuable in planning sustainable supply chains. Now, to get even more precise, the assessment was first done at the national level and then refined down to the NUTS 3 regional level. By going all the way down to NUTS 3, we were able to pinpoint the most important locations for the bio production plant, with feedstock availability being one of the most critical factors in the decision-making process.
Hypothetically speaking, if we wanted to power all EU flights with sustainable aviation fuel, how much of it would we need? Or is it even realistic?
That is a really important question when we talk about the future of aviation in Europe. According to the RefuelEU Aviation Regulation, the EU has set clear targets for integrating sustainable aviation fuel into the sector. We are starting modestly with 2% of SAF requirements by 2025, but the ambition scales quickly, all the way up to 70% by 2050. To put this into perspective, according to the RefuelEU Aviation Regulation, the demand for aviation fuel at EU airports is projected to be around 46 million tons by 2030. Based on this, meeting the 70% of SAF target by 2050 will require producing approximately 35 million tons of SAF annually. And starting in 2030, there is an additional requirement, a sub-mandate for synthetic fuels like e-kerosene, e-methanol, etc., with the overall SAF share. Our project contributes to this vision by examining whether the solar fuels produced using advanced technology and waste-based feedstocks can meet the technical and chemical requirements to be classified as drop-in fuels, or at least to what extent they can be blended into conventional fossil jet fuels. Beyond just fuel quality, we are also exploring how to build efficient supply chain model, from sourcing the feedstocks to converting them into SAF, with a strong focus on both scalability and sustainability of the production pathways we are developing. So in short, meeting the EU's aviation fuel needs with SAF is a massive challenge, but also a major opportunity, and our project is helping lay the groundwork to make it viable.
You work with what are called advanced biofuels, fuels made from waste rather than food crops. How much of these are actually available in Europe today?
The most recent data I can refer to goes up to around 2020, and it still paints an informative picture. So according to the Advanced Fuel Project, which is a recent Horizon project, and their publication entitled Advanced Biofuels to Decarbonize European Transport by 2030, the average share of renewable in transport, that includes biofuels, green electricity, hydrogen, and so on, rose from just 1.5% in 2004 to 8.3% by 2018. Zooming in on biofuels specifically, total consumption reached 17 million of oil equivalent in 2018, up from 15.4 million tons of oil equivalent the year before. That is an increase of roughly 2 to 3 million tons of oil equivalent per year, a steady upward trend. In terms on energy content, biodiesel sales was 82%, bioethanol was 17.1%, and biomethane fuel was around 0.9% respectively. The blending of conventional biofuels estimated at 4.1%, well below the 7% cap set by the Indirect Land Use Change Direct and RENT 2, while blending of advanced biofuels is estimated at 1.2%. The majority of these, as recorded by the Europe-Observer survey in July 2020, 3.5 out of 4.8 million tons of oil equivalent for EU28 in 2019, is produced as fatty acid methyl ester for biodiesel from waste fats and oils, with only a small percentage from agricultural and forest byproducts such as used cooking oil, tall oil, and cellulosic feedstock oils. So, while the share of advanced biofuel is still relatively small, the foundation is there. Scaling this up will be critical if we are serious about meeting the EU's climate and transport decarbonization targets.
Now, here's something that I really wonder. Do farmers actually want to give up their leftover crop material? Isn't that stuff sometimes used to fertilize soil or, I don't know, feed animals?
That's a really important and complex question. And honestly, it is not something we can answer with certainty right now, as willingness can vary widely depending on regional practices, economic incentives, and environmental awareness. That said, we have absolutely taken this issue into account. In our project, we have assessed the sustainable rate of removal from agricultural residues, particularly wheat and rice straw, because we know that excessive removal of these residues from fields can reduce long-term soil productivity. This project aims to provide, at a high level, an innovative technological approach to the production of SAF, as assess it using a systemic multi-criteria cradle-to-grave life cycle assessment approach to monitor such border shifting and promote the most environmentally benign technological solution. Let me just tell you that one of the fast pyrolysis byproducts is biochar, which is mainly used for soil application and is known to improve soil nutrient availability, aeration in soil water filtration, and also provides a carbon sink on agricultural lands. So while we cannot yet speak for farmers' preferences, our project provides evidence-based insight into how environmentally friendly byproducts like biochar can be returned to the soil, helping close the loop. This aligns with bioeconomy and circular economy principles, making agriculture, fuel production, and climate goals work in harmony. We also believe that by providing clear data on environmental performance and economic feasibility, we can support better decision-making for policymakers, stakeholders, and farmers alike.
There has been some concern about using imported waste wood, I believe, in this project. How is Circular Fuels planning to handle that? Is the goal to stay local or something else?
So, as we touched on earlier, our focus is on using waste wood types like demolition wood and plywood sawdust, which are already generated across all EU member states. Now, of course, the volumes differ from country to country, but the key point is this type of waste exists in all EU countries. The real challenge is not about importing waste from outside the EU, but it is about figuring out how to better coordinate supply chains within Europe. That's exactly what Circular Fuels project is aiming to address. We want to explore how EU countries can work together to make the most existing waste resources and build a system that is both economically viable and environmentally sustainable.
One of the challenges your project faces is getting, as we discussed about advanced biofuels, is getting enough of these advanced biofuels. How are you actually tackling that, and is it possible to scale them?
Absolutely. This is one of the core challenges we are addressing in the project. Let me start by saying that we have gathered comprehensive historical data covering the past 20 years for all 4 types of feedstock we plan to use. This includes waste wood and agricultural residues, and we have assessed their sustainable availability across all 27 EU member states. What is more, we have forecast this data into future scenarios, looking at both short-term goals in 2030 and long-term targets in 2050. Additionally, we have mapped everything spatially to show regional distributions and trends, which help us understand where feedstock is available and in what quantities. But data alone is not enough. So we will evaluate the scalability of production and the deployment potential in selected EU locations. This includes identifying and addressing key technical and logistical challenges associated with scaling up the chosen technologies from the current TRLs 3 to 4 to demonstration and full-scale commercial plants. Circular Fuels takes a whole value chain approach. That means we are not just developing new conversion technologies, we are also looking at the entire system, from feedstock sourcing and transport, all the way to SAF productions. We are building regionally tailored efficient supply chain models, and ensure reliability, scalability, and sustainability. And to guide that process, we are conducting a multi-criteria life cycle assessment and life cycle costing analysis. Again, looking at both 2030 and 2050 horizons. This helps us pinpoint not just where we can scale up, but how to do it strategically and sustainably. So, in short, ensuring enough advanced biofuels is not just about finding waste feedstock. It is about creating an integrated system that supports long-term, large-scale production and, of course, secures sufficient volumes of advanced biofuels to meet the future demand of the aviation sector.
Big picture now, if we, let's say, replaced fossil kerosene, which is, for those who don't know, that's the dirty jet fuel currently in use, with your sustainable alternative, how big of a dent could we make in greenhouse gas emissions?
Okay, let me tell you that there is no question that sustainable aviation fuels have a crucial role to play in cutting greenhouse gas emissions, especially CO2. Now, as for how much of a reduction we could actually achieve, that is one of the key objectives of this project. It is part of the work being led by Vienna University of Technology, where we are carrying out a detailed life cycle assessment. For anyone not familiar, life cycle assessment is a standardized tool for assessing the environmental impact associated with all stages of the entire life cycle of a product, process, and service. In our case, we will be assessing emissions from biomass collection and transport, pretreatment, upgrading, final fuel production, and also byproducts use over a defined time frame, which means for 2030 and 2050. Just to put things into perspective, the transport sector is a major contributor to CO2 emission, and within that, aviation alone accounts for around 14.4% of EU transport emissions. Studies so far suggest that advanced biofuels, and that includes, but is not limited to biokerosene, could offer 60 to 70% emission savings compared to the fossil counterpart when assessed over the full life cycle. That said, we are not guessing here. More precise numbers of the potential greenhouse gas emission reductions specifically for the technologies evaluated in our project will be provided at the conclusion of our project.
Well, those white trails planes leave behind in the sky. I recently heard that they can actually add to global warming too, not just the CO2 form engines, but also those white trails has an impact on global warming. Can your fuel help reduce those as well? And how do we even know if it works?
That's a really insightful question, and the short answer is we're actively investigated as part of the project. We have specific work packets dedicated to studying exactly how sustainable aviation fuels behave during combustion in jet engines. This involves both experimental testing and advanced modeling techniques to assess emissions. Once the data is available, we will integrate it into our cradle-to-grave life cycle assessments later in the project. So, while it's too early to quantify that reduction right now, this is something we are taking seriously, and it is being thoroughly studied to provide science-based answers by the end of the project.
And since we're talking about this, I'm also thinking about the people working in the airports. Could switching to cleaner fuels actually improve their health also, given that they're often exposed to, I assume, exhaust and fumes?
Oh, so about that. Switching to SAF could reduce emissions like sulfur oxides, particulate matter, and potentially nitrogen oxides, depending on the feedstock process, of course. However, the main benefit of SAF is system-wide environmental impact and not so much the occupational health, which is, of course, not compromised by SAF.
And finally, a big picture concern. How do we make sure that using waste for fuel doesn't cause new problems for land use or ecosystems? How do you balance sustainability in scale in general?
The project takes a comprehensive sustainability approach. We rely mainly on waste biomass like wheat and rice straw, with careful management to avoid over-removal and protect soil health and carbon stocks. We also reintegrated byproducts like biochar back into agriculture to support nutrient recycling and reduce reliance on synthetic fertilizers. To cut emissions, we are using solar energy to heat the pyrolysis process and photovoltaic system to generate the steam and hydrogens required, replacing fossil-based inputs with clean energy. Together, these measures will safeguard land resources and contribute to climate mitigation while enabling the sustainable production of advanced biofuels. On top of that, the project aims to deliver an innovative technological pathway for producing sustainable aviation fuels, evaluating through a systemic multi-criteria cradle-to-grave life cycle assessment using the holistic recipe framework. This LCA will monitor potential burden shifting across impact categories and help identify the most environmentally favorable technological solutions, ensuring that the project advances climate and sustainability objectives on multiple fronts. Altogether, this helps us produce advanced biofuels sustainable while protecting land and contributing to climate mitigation.
That is great, Stavroula. Thank you for your answers and good luck with this amazing project. And thank you for joining Everything is Changing.
And I thank you, John, for the thoughtful questions. I truly enjoy being part of this, and I'm looking forward to see how the conversation around sustainable aviation continues to grow. Thank you.
That was my conversation with Stavroula Zervopoulou. I really enjoyed hearing how her diverse academic background and hands-on industry experience feed into the Circular Fuels project and its vision for cleaner aviation. If you liked this episode, please follow Everything is Changing on your favorite podcast platform and share it with someone curious about the future of sustainable energy. Perspective is everything, and everything is changing. See you next time.